Okay. Good morning to all of you. Um, so today we are going to see some very interesting topic. Why should we learn AI? So that is a topic that just wanted to share some of my experiences with you on. I am Sudarshan, and I lead the scientific research at Buddy.ai. And so we are a very large team of researchers, engineers, data scientists, analysts, you name it. And so I have been practicing AI for the past 2 decades. And my company Buddy is active for the past 8 years. And so we have a lot of rich experience in fostering AI in young fellows, right? So I just wanted to share some of my experiences in giving you some insights on why you should pick AI as a career, or how do you make yourself AI enabled so that you stand out compared to other, let's say, resources, right? Um, so, so let us start. So I'm going to share my slideshow and let's walk through it. Great. Um, Applied AI. Why should I learn it? So that is the topic we are going to spend some time on today. And applied AI means building applications using AI, or making an application leverage the AI potential to make it more practical, let's say less expensive in the long run at least, and make it more interesting, right? So applied AI means anything or any application that you can build which uses some form of AI in it to make it smarter and efficient, if it is possible, and more interesting. So let us keep it as simple as that. Let's move on. So, why is there a hype? Why is AI being hyped a lot? So there are a lot of sci-fi movies which we watch, and AI is portrayed in various forms. And if you are a subscriber to Netflix, you will see even more material, or even more movies and teleseries that talk about AI changing the way humans live today and in the future. So there is a general feeling that AI is going to be the future of mankind. So this is a direct and indirect message we have been receiving from everywhere. So that is creating a lot of noise around applied AI and practical applications of AI. Secondly, is it rocket science? So usually rocket science is a metaphor, or let's put it, um, a catchphrase used to describe something that is very complicated to understand, right? So people say, is it rocket science? Can you not solve it? So that is a standard phrase people use when they want to compare the work that is being done against the most complicated work in the planet, which is rocket science. But I don't believe rocket science is more complicated than today's AI powered systems. There are much more complex systems which are built out in AI, which might easily overshadow the kind of complexities involved in rocket science. Of course, rocket science is complicated. I don't disagree to that, but I won't say that is the most complicated problem today. We solve much more complex problems in today's world. The next thing is it black magic? So anybody who talks about AI, they think anything that is using AI is some kind of black magic. So black magic is an event which you cannot explain. So that's what we call black magic in general. So is AI black magic? So should I learn black magic and pull off surprises to a lot of fellows? So, as an AI practitioner for the past 2 decades, I totally disagree to that. AI is definitely not black magic. It is, in fact, pure math. Every aspect of AI can be argued, can be justified, and can be explained to a greater extent. So it's definitely not black magic. It is very deterministic. Of course, there is some sort of stochasticity here and there, but the larger chunk of it is deterministic. So we can predict what is going to come out of a particular problem as long as we have a thorough understanding of the underlying math and the science under the hood, right? The next interesting thing that makes AI very attractive is, do AI folks get paid a lot? So if you say you know AI, will you get a job that pays you a lot? So that is very hard. Yeah, right. So anybody, why would someone not pick a job which pays you more? And in today's world, companies are willing to pay fellows who say they know AI a lot of money, because the employer do not know how to do AI, so they want to use fellows, or they want to offload the task to fellows who understand AI a lot, and they're willing to pay big money for it. So most of today's startups, if you want to call it that way, they try to solve these problems and get paid by larger employers. You see the point, right? So it's not just individuals who try to acquire the AI skills to get paid more. It is also a lot of startups who want to create AI skill set or AI capabilities which they can sell for a premium money to a larger employer or a larger corporation for a lot of money. So that is definitely attractive, and that is a big reason for why there is a hype. And these are all the next few questions are some, rhetoric questions, you want to call it. um, uh, right. So are machines smarter than us? Probably some machines are smarter than some humans, but we cannot make a blanket statement that machines will always be smarter than all the human beings. That will never happen, because machines are also created by humans. There will be a time when machines may start creating machines. That is a time we may have to ask this question again, but not anytime soon. So that is good news. So machines have no way of becoming smarter than humans, said as a blanket statement. So the next follow-up question is, will machines replace humans? Absolutely, they will replace humans if the human is not upskilling themselves, right? So this is a standard thing in any system, right? So if you don't upscale yourself, you become obsolete, and you become replaceable by something better, right? Why do we change our TVs? Why do we change our phones? We change, many of you might be changing your phone every 6 months. I mean, I change my phone once in several years, but I'm from a different generation. But today's younger fellows, they change their phones every 6 months because they think the next phone is better than the previous phone, right? So a new phone is replacing an old phone, but the function is the same. So in both phones, you talk, and you do a lot of social networking. And in the new phone also, in the older new phone, you do the same thing. And why are you changing it? Because the new phone is faster than the older phone, and probably the newer phone is cheaper than the older phone. So the same logic applies to humans also. So let's say if I am someone discharging some skills and capabilities, and if someone else is going to discharge the same skills and capabilities, probably faster and probably cheaper, then I will definitely get replaced by the other human being. And this is how life progresses, right? This is how evolution happens. So if machines have the same skill sets that of a human, and if machines can do the job better, if machines can do the job quicker and cheaper, definitely machines will replace humans. But is that a threat? Probably not. It is probably not a threat. Humans can always outshine machines, because humans can learn diversified things if they have the intent to learn. So continue your learning, and keep replenishing your knowledge, and keep learning. And as long as you keep learning and be relevant to today's market, you can never be replaced, even by the best machines of today and tomorrow's world. So it is a responsibility of the human beings to stay front or stay ahead of everybody else. So that is what we are looking at here. The next question: are we becoming cyborgs? Cyborg is a combination of machine and human in one package. So I don't think we are going to worry about cyborgs, at least for the next 1 decade. But yes, sooner or later we will become cyborgs. So today, many of the human body parts are replaced or replaceable. So the knees are getting replaced, the hip joints are getting replaced. For some people, the hearts are getting replaced. So anything that can get replaced, we are welcoming it today. And there will be a time when 70% of the body parts are synthetic. Just think about it. It is definitely going to happen, but probably not in the next 10 years. Maybe in the next 20 or 30 years, it is definitely going to happen. Most of the body parts will be synthesized. And you may get synthetic body parts if your natural body part wears out. And as a natural next step, you may have humans with only synthetic body parts. So cyborgs is definitely going to happen, but not immediately or not in the near future. And we don't have to worry about it, because we will not really know the difference between being natural or being synthetic or being a combination of that. So we will not be we cannot see the difference. So it's okay. As human beings, we will also welcome cyborgs, and as cyborgs, we will also welcome human beings. It's a two-sided statement. And is Spielberg's prediction true? I'm referring to the Terminator movie. I don't think humans would be outshined by machines the way Terminator movie portrayed. I don't think it's happening that way. It's more of an inclusive thing. We may become cyborgs, or cyborgs and humans may coexist, and ultimately cyborgs may outshine natural humans. I think it will evolve. The humans will definitely evolve to cyborgs. That's what I am thinking. I don't know if I will live to see that, but that would be a very interesting thing to watch in the time frame. Moving on. So let's get to the chase. So we are referring to intelligence, right? We are referring to AI, but let's try to understand the fundamental definition of what intelligence means. Just think about it. We call ourselves as intelligent beings, but do we know what intelligence is? So let us try to define that. So it is the ability to acquire knowledge and apply them to solve problems. If you have the ability to acquire knowledge and apply them to solve problems, you can call yourself an intelligent being, right? So it is a continuous process of acquiring knowledge and application of the acquired knowledge. So if you do one part of it, you cannot be intelligent. You can be called knowledgeable, but the moment you discharge that knowledge to solve a practical problem in hand, that is when you become intelligent, right? So just keep that in at the back of your mind. So how do we acquire knowledge? So think about it. So I'm not referring to the knowledge that you acquire by reading books. Not only that, that is definitely a part of knowledge, but that's not the only way we acquire knowledge. Our knowledge is acquired predominantly by our experiences, right? So every experience we undergo, that acts as a reinforcement of the knowledge that we have acquired so far, right? So we gain our knowledge only by experience. So when you tried your cycle for the first time, I'm sure you would have fallen down, right? And when you tried it for the next day, on the next day, or in the next week, you would have definitely become better, and probably in a week or two you would know how to ride a cycle. How did that happen? Every time you took a cycle and attempted to ride it, you are experiencing something, which is how do you balance your body on two wheels, and how do you negotiate, or how do you maneuver the cycle in a specific direction, how do you go forward, how do you stop the vehicle. All these are experiences, and you experience by trial and error. And when you fall down, you know it is a bad experience, so you want to avoid it. And when you are able to when you are able to run your cycle stable, then stably you can you it's a reassurance that you are doing the right thing. So you experiment, you make a trial, and you look at the outcome of the trial. And if the trial is positive, you consider that as a reinforcing or reinforcement of the knowledge acquired. Or if the trial went out bad, then you say that is a negative example and I want to avoid it next time. So that is the knowledge that you acquire. So humans acquire intelligence only through experience. Some people may fast track their experience by imagination, right, or by listening to other people's experience. So you don't have to experience everything firsthand. You can also listen to other people's experience and learn from it, right? In the machine learning world, we call it the transfer learning, but humans have been historically doing transfer learning. So I don't have to experience fire by touching it myself. If my parents say that if you touch fire, you will feel a lot of pain in your hand, or and that itself is good enough for a lot of us to experience fire firsthand, right? There are few of us who would further ourselves and go and touch it and get the experience firsthand. It is also good, but not necessarily all the time you should get the firsthand experience, right? You don't have to. You just learn by listening to others. You learn by observing other events and other people, and that is also a lot of reinforcement on the knowledge that you have acquired. And you can apply those knowledge in decision making when you have to take a decision yourself. Great. So can we make artificial experiences? So we said we gain all our knowledge through experience, but can we synthetically create experiences? Absolutely, we can do that. What do you think your teachers do? So when they want to teach you something, and they try to give an experience by giving a lecture about it, and by illustrating whatever they are trying to teach you. What am I doing now? I am actually trying to give you an experience of how to go about understanding artificially intelligent beings, right? Every teacher's job is to create experience for the students so that they can gain some knowledge from it and proceed with applying those knowledge when they have to apply the knowledge to solve problems, right? So experiences can definitely be synthesized for oneself and for the others. So a teacher creates the experience for the students. You can create experience for your own self to learn from it, right? So let's say you want to cook a food, right? You want to try cooking a meal. How do you improve yourself? You try it repeatedly. You repeat the process 2 or 3 times until you understand what is the right proportion of different ingredients to make it taste awesome. And every time you decide to repeat the experiment, you are giving the experience to yourself. You are giving the experience to yourself. So yes, artificial experiencing is possible. You can do that. And in the computer world, these experiences can be simulated, right? So that is the beauty. So when you look at machines involved in the experience process or involved in the knowledge building process, a lot of things can happen faster because computers can do the computation faster, right? It is just the computational part, not anything else, right? So if you can represent an experience as a computer understandable thing, then these artificial experiences can be created in bulk, and they can also be deployed in bulk. So there is a possibility of you learning something very fast by creating artificial experiences. So if we can create artificial experiences, and if we also uh, know how to apply these experiences into solving problems, then can we create things which are artificial intelligence? Oh, yeah. Yes, you can do that. You can do that. And this is the very idea of AI being learned as a topic or being learned as a skill, right? And how do we solve it? We solve it mathematically. So mathematics is a brilliant tool which helps you visualize things that you cannot visualize. Simply put, simply put, math gives you the eye to see things which you cannot see with your physical eyes. So I would call math as the comprehensive visual power. It gives you visualization power um, by mere math, right? Anyways, think about it. Moving on. So now we have understood what is intelligence and how we can create experiences and how we can, or is there a possibility of creating something which is artificially intelligent? So far, so good. So moving on. Let's look at artificial intelligence. So who do we call intelligent in general? So in a classroom or in your office or in your home, we always often compare ourselves with others, and others also compare us with others. That is a bad thing, but we'll have to compare ourselves with people whom we respect, so that we can reach their level and beyond, as long as we put the effort to do that. Okay, so who do we call intelligent? Someone who takes correct decisions faster, backed by explainable information. This is one line explanation of how we see others as intelligent. Let's say if I am stuck in taking a decision, but my friend comes in, listens to the story, and he gives a verdict and moves on, and you will look at him like, what is happening now? How is this guy able to understand the situation and give a solution without any thinking process? Oh, he should be really intelligent. I should learn from him. That would be the mind voice, right? Usually when you see your friend solving a problem which you were struggling so long for solving. So usually um, when we see others taking decisions faster, and they are also taking decisions which are correct, and they are also able to explain why they took the decision, we definitely see them as more intelligent than us with respect to that particular problem, right? And we want to learn that. We definitely want to learn how they solved it, how they pulled it off, right? So we call somebody who can take decisions. And you know what? The most difficult task for a human being is taking decisions, right? And the ability to take decisions do not come with experience. They are, I think, inborn. There are people who take decisions fast. They don't really care about the pros and cons of it. But I'm not referring to such people. There are people who are, what to say, very procedural and pragmatic in taking decisions. So they say, I will not put my mind into taking decisions, I will put my brain in taking decisions. I look at what are the information that is available with me and what are my choices, and based on the information I'm going to take objectively some decision, and I will hang on to it, no matter whether it is going to be good or bad. I'm going to hang on to it. So those people are ones which we have to revere a lot, because they will be the most happiest fellows ever, right? Because they will not feel bad if things go wrong, because they took the best effort to take the decision based on whatever information that was available. So they did their part very well. So they will never feel bad for things going wrong, and they'll take everything in a positive stride. Okay, great. Moving on. uh, so just taking decisions, is that enough? No, it's not. It's not really enough. So we'll have to convert those decisions into actions, right? And when decisions are converted into actions, that is when the prowess of the decision would be measured. For example, if I throw a problem at you, I want to go to Jupiter, give me a plan. So you give some decision, you take some decisions and give me a plan. And you can say that you can build a rocket in your backyard and make it fly, and it should have unlimited fuel and unlimited life support, and that should take you from and that should be unlimited, that should have unlimited speed, and that will take you from Earth to Jupiter in no time. So that can be a plan, and that can be a decision, but is that decision implementable? Probably not today. So a decision taken faster, backed by explainable information, is not just enough. The decision should also be practical. So that is what I'm trying to convey here. So because once you have taken a decision, and if you find it very hard to implement the decision, then whatever decision you take is not going to be useful. So this is why the most difficult job for a human being is taking the correct decisions that are pragmatic and that are practical and implementable. And this is why most of the times we offload the decision making process to others. Sometimes the others being machines or systems. Think about it. Okay, this is a counter question to you. So when an animal exhibits such character, we call it intelligent also, don't we? When we see that our dog is able to open the door by using a handle, we call it intelligent. But I don't call it intelligent. It is just muscle memory. It is practice. It is training. So when you ask your dog to sit, it sits. Do you call that intelligent? You don't, because it is a command that the dog is following. Likewise, if you trained your dog to open a door by twisting the handle, the dog is going to take it. The dog is going to do it. So that is not really intelligent. So intelligence is not about doing things. It is about taking decisions given the situation. And also the decisions that we take should be implementable. So let's try to understand that. And whatever decision that the dog takes is called the natural intelligence, because the dogs are born with it, humans are born with it, birds are born with it. How are birds flying from one point to another? They don't have maps with them. They use some sort of magnetic alignment to move from one place to another when the distance is longer. And is that acquired intelligence? No, it is inborn intelligence. It is natural intelligence. And they have hardware in their head to align their flight towards magnetic orientation. Right? Those are like amazing hardware that we can have inside the body. And I'm sure humans also were having such hardware before, but now I think we have forgot how to use that capability, because we do not want to take decisions. We don't want to become intelligent. Okay, so when something didn't have intelligence by nature, right? I call thing, right? Just watch the word. When something which did not have the intelligence by nature, but made intelligent by external means, we call such things as artificially intelligent. Let's take a computer, for example. A computer which knows how to recognize a face, right? When the computer was made, it was dumb. It did not have anything. But when you give that skill to the computer to recognize the face, every time you get in front of the computer can greet you. Hello, Sudarshan. Good morning to you. Right? So as when my computer recognizes my face, and so the computer knows to identify me, and it can also use that identification as an authentication mechanism. For example, my laptop uses face recognition to unlock the screen. It uses some features on the face to recognize me, and it unlocks my screen. I don't have to type my password. It just my face is my password, right? And that is definitely intelligence, because the machine knows to recognize the right human being. It knows to decide based on what is the image that is seen by the front camera. And how did it become intelligent? Because we made it intelligent by giving the skill of acquiring the data, which is the photo from the front camera. And we also gave the machine the skill to understand the information on the photo, compare against a dictionary of the faces, and say, this is person Sudarshan, this is person John, this is person Muhammad, right? And how is it doing it? It is just following the instructions that we gave it. and that is the external means I refer to. So a machine which is naturally dumb is becoming intelligent by running a piece of code that I have given the machine, which is the external means I refer to. And now the machine has become smarter to identify a human being just by the picture collected on the front camera. And you're also going to learn that uh, this weekend, right? All of you are going to learn how to make a machine recognize a face and how to make a machine intelligent in recognizing a face. So a thing which is naturally not very intelligent or naturally not intelligent but can be made artificially intelligent by external means, and when it has become artificially intelligent, great, very nice. And can we extend it further? Can we make it intelligent on other tasks also, not just the face recognition application? Yes, absolutely. You can make machines intelligent on several other fronts. Sure. But for that, one lecture is not probably enough. You need a lifetime. You have to make it a career. So I welcome you all to the AI career. Moving on. So the next thing which we'll have to pay attention to, which is also very hot in the market, is called the analytics. So there are a lot of jobs which are created in the analytics field. In fact, Buddy.ai, the company which I work, is also having a lot of openings on AI, on AI and also analytics. So if you think you fit the requirement, please come to us sometime. Okay, let us try to understand the terminology. So analytics is a word created from the root word analysis. So slicing and dicing data, or understand the situation by analyzing it, analyzing the whistles and bells and whistles and outputs and whatnot, right? So I see that analytics is composed of two things. One is discern and another is analysis. Discern means you just divide the data into different aspects and analyze different aspects. The combination of divide and conquer, not the divide and conquer in the algorithmic world. Discern is a word which says you have to look at the information from different aspects, different laterality, to understand it better. So that is the intent of discern, or dexterity, you can call that also. Discern plus analysis equivalent to analytics. And there are four types of analytics which are possible. Let's look at that. So there are four levels of analytics. You can also call it four types. And the graph in front of you shows the progression, right? And we can answer four different types of questions. So the first one is, let's say something has happened and I do not know what has happened, but I seem to have collected data about what has happened, or I seem to be collecting data about everything happening in my universe, and I want to understand what are the different things that happened, right? So descriptive analytics is a type of analytics which addresses this question of what happened, what has happened, right? And the next thing that we can also look at is the reason for why why that event happened. So diagnostic analytics is another type of analytics which tries to find reasons for why that event occurred in my universe. The universe that I refer to is the data, right? Whatever data that I've collected, that's what I call the universe, right? So the second level is the diagnostic analytics, and the third level is, okay, this is going to get interesting now. Okay, events occur and we also know the reasons for those events. Okay, can I use this knowledge to predict what is going to happen next? Can I do that? So the intelligence coming here, right? So descriptive and diagnostic both are the knowledge phase, right? You collect data, understand the data, which is descriptive, and you collect data, understand it, and also find reasons for why something happened, which is diagnostics. And these two are the knowledge phase. And predictive analytics is the start of the intelligence phase, where you try to apply the collected knowledge to predict what might happen in the future, right? Let's go one step further. which is called the prescriptive analytics, where we say, okay, something is going to happen in the future. What should I do to circumvent that? Or what should I do to handle that? So that is the prescriptive analytics. So which will answer, how can I make it happen, or what should I do? What should I do to handle it? So that is the prescription. When something will happen or what will happen next, it's the predictive analytics. And what should I do when that happens, or how can I make it happen? Those questions are a part of prescriptive analytics. Both are intelligence based, right? And we can also divide this into three sides. So insight is the phase where you understand what is happening, and you also understand why something is happening. And thirdly, you also understand what might happen next. So that is the insight, right? And the foresight is you be prepared for what is going to happen next. When I know what is going to happen next, and when I also know what should be my action taken to handle the future event, then that's called foresight. And when I'm looking at the historicals, when I look at what happened in the past or what has happened today or yesterday, that is the hindsight. So insights are the most important thing, because that acts as the center point between hindsight and foresight. I'm really sorry about the noise. Okay, moving on. Okay, so far we have seen AI a little bit, and there are these terminologies which are being used often, right? So AI, data science, machine learning, deep learning. How many more terminologies will we have to dabble with, right? So let us try to understand what are these terminologies. Are they the same, or if they are different, how are they different? Let us spend a few minutes on that. So, in my opinion, there are several definitions for data science, but this is my own definition. Data science is a discipline of study which covers all the aspects of data handling and harnessing techniques and systems. So, what we want to do is, we know that the future of mankind is going to be data powered. Shoot. Sorry about that. So the future of humankind is going to be data driven, and we need to have a program which fortifies human beings to understand how the future is going to be handled. And in my opinion, data science is a discipline of study, so it encompasses everything that one person should know to visualize the world as data, right? So companies which visualize the world as data have become billions and trillion-dollar companies now, right? Maybe several billion-dollar companies. For example, Google was the first one which saw the world as a data set. Then Facebook made it worse, and they saw every human being as a data point. And Amazon leverages it, Microsoft leverages it, you name it. All the larger corporations want to see the world as a data set. They see the world as a data set, right? And Google was the first one to start this. Of course, I definitely want to give the credit to them. And yeah, which is also true, because the entire planet is moving in that direction. So not just Google's and Facebook's and Microsoft's and Amazon's. I think every individual should start accepting the fact that we are moving into a dimension where everything is data, including myself and yourself. We have to accept that fact, that we live in a universe where everything is seen as data. Okay, great. So do I want to be a part of it, or do I want to be a rebellion side? That's a choice we always have, right? In my opinion, whether you are for a data driven world or against data driven world, it is absolutely necessary that you learn data science. Because there is a saying, right? If you want to fight an enemy, you should know about the enemy. So if you're working for the data driven world, you have to learn it, because it's a part of your job. And if you want to work against the data driven world, you have to still learn about your enemy. So whether you are for it or against it, learning data science has become necessary today, right? So please consider data science as your as your career, or at least you can endorse data driven thinking, that solves a lot of problems. So data science is a discipline of study, in my opinion. Great. And so data science is a combination of multiple things. So we have, in today's definition, it's the amalgamation of mathematics, statistics, domain knowledge, and business knowledge, and computer programming. So all these three things put together, you get the field. You get the field for data science. I'm not saying that is data science. You get the field for data science, where you can apply whatever you learn in the discipline of study to become relevant, and to create something useful there. That's how we should see it. Okay, so data science focuses on creation, manipulation, transformation, distillation of raw archived data into information turned knowledge, with which one gets empowered to do informed decision making. Again, this is my definition. This is not taken from a textbook. Okay, so the idea is, this is what I meant by data driven world. So everything that we are going to do is going to be powered by data. So our decision making should always be powered by information around the problem statement. So that's called informed decision making. So data science allows you to put all the data that you have around you to use to get there. The destination where you want to be is informed decision making. So you want to be empowered by informed decision making. So that's what data science will help you say. Great. Then what is machine learning? So machine learning, okay, the definition of it is a combination of applied statistics and optimization theory. Both are age-old topics from the mathematical world. Applied statistics and optimization theory both have more than a century lifetime, right, already. So they are like seasoned mathematical subjects, and machine learning is a manifestation of their combination of statistics and optimization theory, right? Interestingly, you should see machine learning not as a discipline of study. Rather, you should see machine learning as a toolkit. So it is a battery of tools that you have to solve problems which are data driven, or which can be modeled as data driven problems. So machine learning is a toolkit that allows machines to crunch data and construct knowledge and intelligence. So machine learning allows you skills, or allows you to use tools with which you can convert data into intelligence. So see machine learning as a toolkit. Don't see machine learning as a discipline of study when you are looking at applied AI. So machine learning can be a discipline of study when you want to take that as your core, or if you want to have a mathematical foundation, or when you want to do a mathematical career, then machine learning can be seen as that, right? I took machine learning as a discipline of study because it is a requirement in my job, and also in my personal interests. But if you are looking at AI as a career path, you can treat machine learning as a black box. You can treat machine learning as a toolkit. Of course, if you understand the under the hood mechanics of machine learning, then you are definitely going to be more powered and more empowered. But that's not really a requirement. As long as you understand the merits and limitations of different tools and techniques, I think you are good enough to sail. And artificial intelligence is realized using machine learning. Machine learning, I said machine learning is a tool which allows you to move from point A to point B. And AI is your destination. So you need machine learning to go there. So artificial intelligence is realized using machine learning. So you construct a house by using a lot of tools, right? So you can say the house was realized using those tools, or the application of tools. That is the parallel you should have to understand this phrase. By the way, data science subsumes machine learning as a very long chapter. So data science has several, I mean, if you want to call several chapters or several phases, machine learning is one very long chapter in it. Because data science talks about data ingestion, right? How do you acquire data? How do you curate data? How do you prepare your data? And once you pass the knowledge construction phase, let's say on the number of the types of analytics, the first two analytics do not really require machine learning. Descriptive and diagnostic, they do not really require machine learning. Only from predictive and prescriptive you need machine learning. So half the journey in data science does not require machine learning at all. It is more to play with statistics and your analytics mindset, right? It is more towards mindset and your orientation and curiosity towards understanding things which are obscure. So data science subsumes machine learning as one long chapter, and deep learning is a subset of machine learning. So deep learning by itself is nothing. See, deep learning, what it does is it uses one specific technique or one specific tool in machine learning, which is called the neural nets. So deep learning is the expansion of the neural net technique under machine learning. So deep learning is definitely subsumed to machine learning. So we cannot say machine learning is different, deep learning is different. If somebody says that, I'm sorry, they have to read again or they have to train themselves again. So deep learning is a part of machine learning, right? Machine learning subsumes deep learning. Data science subsumes machine learning. Understand it that way. So since deep learning is a part of machine learning, deep learning is also a toolkit. So understand this as a toolkit, right? And deep learning allows you to model really complex systems, because deep learning by design is very complex. And it is just another toolkit under the machine learning toolkit, right? But this deep learning toolkit is huge. It's a lot of tools under the hood. So if you want to pick up mastery in deep learning tool, then you can spend a lifetime on it, because it is that vast. It is that vast. Then consider machine learning should be vaster than that, right? It's a nice journey if you take it nice and slow. It's a wonderful journey. So AI, data science, ML, and DL, they have different purposes, different meanings, right? And data science is a field of study. Machine learning is a toolkit. Deep learning is another specialized toolkit, and AI is our destination. So this is how we'll have to understand this. Okay. So the journey of you picking AI as a career. AI should be the goal. So my goal is to make everything intelligent. So I call it smartify, right? So make something smart. And the way you do it is by endorsing AI in whatever way possible on a task which is data driven. So if you are working on a task which is data driven, and AI uh, uh, implementing solutions with AI should be straightforward, because there are ready-made tools and techniques available to do that. So my goal is to smartify a data driven problem, right? My goal is to smartify it or make it smarter. And so I call it as AI being the goal, right? And look at this diagram. This is a depiction of what we saw previously. So data science is cutting across all of this because it is the discipline of study. So data science is the path. So AI is my goal, data science is the path to the goal, and machine learning is a tool. Of course, deep learning is subsumed by machine learning, which calls deep learning also as a tool. Look at the diagram here. So deep learning is fully engulfed by machine learning, and machine learning is a tool with which you realize artificial intelligence, and data science is the path to take you from nothing to smartify, or to becoming artificially intelligent. So that's about the journey. And let's answer some interesting questions now, which is supposed to be our original target. So why is everyone learning AI? Okay, now we understood some foundations of what is AI and whatnot. So predominantly because there is a demand in the job market, right? 15 years back, this hype was not there. And people did not even think about AI being a course. I mean, I'm talking about over publicized or over socialized courses. Of course, AI was a course in institutions for the past multiple decades, but it has not been dummified, or it has not been socialized a lot 10, 15 years back. But today, every nook and corner, you get a training institute. And today, you have 100 different websites which give you training on AI, right? Why? Because a lot of people want to learn AI. Why? Because a lot of employers want to hire people who know AI. So there is a lot of demand in the job market. Let us understand why there is a demand. So the first objective of an employer is to reduce their operational expenditure. They call it OPEX. by adapting automation. So whatever I've been doing manually by using manual labor, I just want to cut it short by adapting to automation. And automation through AI would be awesome. So automation, it all started with automation. So automation and AI are different, so don't mix it up. Automation does not mean AI. If you say AI automation, only then it is AI. So automation, there are a lot of automation companies, they call it RPA, robotic process automation. And RPA is not AI, it is not necessarily AI. You can do RPA without AI also, but a combination of RPA with AI would be a killer combination. That would be really cool. So the first objective of why data science or AI became popular is because employers wanted to cut cost by adapting automation. The second thing is the companies, industries, and employers, they seem to be collecting a lot of data about their processes, about their people, about their machines. A lot of data is being collected, but they do not know how to put them to use. So industries opened up this demand of finding resources who can help them put that data to use. So industries want to put the collected data to help them understand their business better. So I understand my business based on my first-hand experience, but there are a lot of data that my industry or my company is collecting, and I don't seem to understand anything from it because I don't have the skills to do that. Okay, so let me hire people who have the skills to do that. And this is why companies like mine are opening up this portfolio in the open world, in the job market. So every company wants to get into this space, they want to put their data to use, and that is why there is more demand. And data science allows for extraction of actionable insights from data. This every employer understands, and that is why they open up positions for data scientists, data engineers, data analysts, right? All these job titles, they are interchangeably used, but they have definitive different meanings. But these job titles are floated often in the market because every employer knows that data science allows them to extract useful and actionable insights from their own data sets. Okay, now the first objective was automation because I want to cut human labor. The second thing is I want to put my data to use to get actionable insights. Can we combine these two together? Can we combine automation and insights together and make it smarter? Can I smartify my operations? Can I smartify my industry? Can I smartify my processes? This is what every employer is looking out for, because the moment I smartify my process, my industry, my people, I seem to reduce a lot of human labor. In some sense, I am reducing a lot of cost, reducing a lot of operational expenditure. So these are some of the reasons why AI hype is there, and there is a lot of demand in the market. And the final thing is, humans don't want to take decisions. So there are companies which allow for humans to avoid taking decisions and make machines or systems take decisions. So this is also why there is a lot of demand in the market, because you have to create systems which can take decisions on behalf of humans who do not want to take decisions. So this is why there is a lot of demand. So when was the last time you decided on your own to order your favorite food? Think about it. So when you open Swiggy or Zomato, there are two ways in which you can order food. One is find the food that gives you the deepest discount, or find the food that gives you 1+1 offer, or find the food that mouth waters you. 90% of the times, you don't order the food that mouth waters you. You order the food that is cheaper. Don't you think? Yeah, because I don't want to decide. I want Swiggy to decide for me. And Swiggy tells me what I should eat indirectly. They make, okay, they make these offers to make themselves attractive, to make food delivery business attractive. But eventually, they are taking decisions on behalf of you. They decide what you should eat for your dinner. And indirectly, you also forget that you are supposed to be the boss there. You have to say what you want to eat, not Swiggy. It's really funny when you deeply think about it. When did you buy a product because you read its documentation and technical manuals? Never. We go to the star rated decisions by others, right? When you buy a phone, you don't buy a phone because you liked it. You buy a phone because everyone says it is good. There are more positive reviews than negative reviews. It is a 4.8 phone out of 5, right? And you decide the brand, or you decide the model based on which model was performing better. And here you have not offloaded the decision making to a machine, but you have offloaded the decision making to other people who have opined their reviews. So again, you did not take the decision. Some random fellow took the decision on behalf of you. When was the last time you called your friend without an address book? Do you remember your best friend's phone number? Ask yourself that question. I remember my mother's number and my wife's number. I remember it. And you need to at least remember 5 or 10 phone numbers which are crucial to you. So if your phone is gone, or let's say if your address book is gone, my God, you will stop calling your friends. Think about it. We are living in such a world where we are becoming dumber and machines are becoming smarter, directly or indirectly, whether we liked it or whether we did not like it. Think about it. These are food for thought for you. Okay, so this will be my last slide, hopefully, because I've already spent about an hour. Okay, so let us cut to the chase and give you the verdict. When are you a data scientist? When can you call yourself a data scientist if you aspire to be one? Can you patiently review through data samples to hunt for patterns? So what I mean by that is there are a lot of data scientists who hate to review data sets, sadly. But in my company, if someone says, I won't see data, I will only work with model building, we give them a piece of our minds, because they have to be taught what it is not to be a data scientist, right? More than when someone can become a data scientist, you have to know what are the things that you should never do for being a data scientist, more than what are the things that you should do to be a data scientist. So if you shy away from reviewing data samples, then you are not fit to be a data scientist. I use this word, date the data. Date the data. So the first time when you look at the data, it will look gibberish. Definitely, it will look gibberish, and you will not make head or tail of it. You will not make any sense of it. But the more the time you spend with the data, right, the data will talk to you back. It is very much like the dating process. So on your first date with your best friend or whatever, you don't expect everything to happen that day, right? I mean, you don't expect to open up. I mean, you won't open up, your other party will not open up, and it will be more of a gloomy conversation. But let's say if you're meeting that person for the fifth time or the 10th time, then things would have become much better. I mean, you will start trusting each other. You will start sharing a lot of information about your lives and your profession and whatnot. So so dating is a continuous process. It doesn't happen in one day. So likewise, treat data as your partner, and on your day one, don't expect your partner to open up. The more the time you provide your partner will start trusting you. I'm not really using the word trust here. It's a metaphorically, I'm using it metaphorically. So what I'm saying is, the more the time you spend with the data will open up. It will show what are the different things that you can leverage from it. It will show what are the potential insights that you can draw from it, right? So that's why I call date the data. So the more the time you date the data, you can become more empowered by the data. So if you cannot do that, or if you shy away from it, sorry, you cannot be a data scientist. You cannot be anybody. You cannot have a AI career if you hate to sit and analyze data. Second question: can you research for existing solutions for a given problem alongside studying the pros and cons of each of those solutions? So this is called literature survey. So when you're given a problem, you are supposed to go back to the literature and read about problems which have solutions documented already. And when you don't have a direct hit, you have to look at problems which are similar to the problem that you have in your hand, and see whether you can leverage the solution for the similar problem onto your problem. So it is kind of transfer. You learn from a different setting and you try to transfer the knowledge to your setting, right? Do you like that, or do you enjoy doing that? Right? So if you enjoy doing that, yes, we are on track. And if you don't enjoy reading other people's work, sorry, you cannot be at all. So can you transfer your problem from one problem to another? Because sometimes, when you are working with a problem which is brand new, you won't find an existing solution out there. But you will have to read, or you'll have to hunt for similar problems, and have the eye to figure out that problem, the problem that you are having in your hand versus the problem that you are seeing in the literature, have similarity. You need to have that eye for finding the similarity and try to leverage from it. So the way you do it is by reading regularly. So when you read a lot, things will be there in your memory. So usually when people do research, they have maintain a journal. They maintain a journal and they'll record interesting readings that they have done during their literature survey, so that when a new problem comes in, you can connect that to the problems that you have seen in the past, and then try to draw a line or connect the dots. That's absolutely necessary. The next thing is, can you mathematically model your data and objective? So data scientist is not about writing code. Please remember that. It is not about writing programs. It is more about understanding the problem and connecting the dots with solutions. And once you have done your homework, implementation is only the last mile. Preparation is rest of it. Everything else is preparation. So implementation is only the last mile. So if you did your homework properly, your implementation will be a smooth sail. You will not have any uncertainties there. But if you jump to implementation on day one, my God only save you. So you need to pragmatically approach solving the problem, starting from the data to the solution, and keep the coding part as the last stage. Understanding the problem, understanding the solutions, that is more critical, and explaining the solutions is more critical than implementing the solutions. So remember that. So when you have multiple choices of solutions for the problem that you have in your hand, do you know how to pick the best technique based on the merits? So don't pick random forest and add a boost, or let's say XG boost for all your classification problems. Don't do that. Sometimes a random forest and XG boost might be an overkill. You might solve it using naive Bayesian. I'm referring to a classifier name. So it doesn't mean you have to always use a chainsaw to sharpen your pencils. You just need a blade, a small blade, to sharpen your pencil, or you need a sharpener. You don't need a chainsaw. So do you know how to pick the best techniques available out there as choices for the problem based only on the merits? If you do not know how to do it, go back and learn about it, and then come to your coding. So don't start your life with coding, or don't start your day with coding. It's a very bad thing. Do the foundations, analyze it, understand it thoroughly, then the last mile will be your programming part. Can you understand your data? Can you characterize your data? Right? Do you slice and dice data? So in the machine learning world, we call it the explorative data analysis. In short, it is called EDA. EDA is not the only thing. There are standard EDA techniques for characterizing the data, but there are more. Characterization is also part of date the data task. So when you date the data, when you work with samples of data to understand what they have, what they can tell you, that is a more involved characterization process. Running EDA on it is not sufficient most of the times. Running EDA is definitely necessary, but it is not sufficient. That's what I'm trying to say. So spend more time with data. So can you solve an unsolved problem by discovery or deduction? So if you have an unsolved problem in your hand, do you have the guts? Do you have the patience to work with the discovery or a deduction? Great. So if you said yes to all of these problems, then yes, you are on the path to becoming a data scientist. You are not a data scientist yet. You are on the path to become a data scientist. So the more practice you have on all these questions, the better data scientist you will become, right? So keep ask these questions to yourself if you want to get data science or becoming a data scientist as your career. You ask your questions yourself every day, at least every week, and correct the gaps, and you will definitely be a better one. So finally, what is an AI enabled workforce? So there are few things which we will need for you to become an AI enabled workforce from the employer's point of view. The first thing is you need to have excellent programming skills. So you should be very comfortable in playing with data structures and algorithms to solve the problems. I mean, see, knowing only Python programming does not help, right? Your understanding on data structures and algorithms are super critical. I mean, if even if you are from a different discipline, even if you are not from the engineering background, but learning data structures and algorithms will be key if you are going to be coding or if you are going to write programs for building the AI applications. DSA is super critical, so you cannot do away with that. The second thing is holding to two languages, so not one language, right? One language is definitely not enough. So I would say fluency in one scripting language, which is Python in most of the cases, and one enterprise language. So in my company we use Scala as our enterprise language. Java is also used, but not by R&D. By research we use in R&D we use only Scala as the enterprise language, and all our researchers use Python for scripting. So try to learn or try to have fluency in two languages: one scripting language, which could be Python, and one enterprise language, which is of your choice, which can be .NET, which it can be Java, it can be Scala. There's several other enterprise languages which are possible. And thirdly, you need to have fluency in using third-party libraries and frameworks for building your application. See, if you choose to build everything from scratch, one lifetime is not enough. So we should leverage things which are already available for use, and you should know how to leverage them, right? And secondly, this is not enough. Only programming skills will not be enough. So you need to have strong mathematical foundations of data science. So you need to translate a given problem into a data driven mathematical model, ability to transform an unknown problem into one or more known problems, ability to pick a suitable solution for a problem based on merits and limits, and ability to understand patterns and perform root cause analysis. These are all super critical for becoming an AI enabled workforce. If you, this is a repeat from the previous slide, but I just gave this slide as a summary. And nextly, you need to have an attitude for lifelong reading, right? You should love reading other people's work. And literature survey and lifelong reading, these are all super critical for having a career here. And finally, you need to have great people skills, positive can do attitude, to collaborate with fellow practitioners, because one lifetime is again not enough to learn everything by yourself. So you have to learn things from others. You have to work as a team, because the landscape is very large. It's super large. So you will not one lifetime may not be enough to learn the entire landscape of data science. So you need to collaborate with other people in the team. So for that, you need to have excellent people skills. You should have a positive can do attitude, and you should have the willingness to collaborate with fellow practitioners. So these are all the key things that you will need for becoming an AI enabled workforce. And with this, I'm going to end my presentation. So I had these slides also, doesn't matter. And thanks very much for the opportunity. And by the way, we are hiring for AI/ML researchers, data scientists, data analysts, Scala developers, UI engineers, and more. So if you think you want to try buddy.ai for having AI as a career, please write to AIMLjobs@buddy.ai. And I thank you very much for the opportunity, and have a great day.